Okay, so I was going through the research stack this morning, and honestly, I had to do a double take.
Mm.
I found a listing for one single HDMI cable,
Mm-hmm.
and it was $884.
And that's the sale price. I think the list price is over 1,100.
That's it. I mean, most of us get annoyed if a cable costs more than, what, 10 bucks. So I have to ask, what on earth makes this Kramer CLS-AOCH worth so much?
Yeah.
Is it, like, woven with gold?
Close. It's woven with light. The key number here isn't really the price, it's the distance. We're talking 328 feet.
100 meters.
Exactly. So this isn't for connecting your Xbox to the TV 3 feet away. This is a professional-grade optical beast. It's designed to push a signal the length of a football field.
Right, but even at that distance, I mean, couldn't a really high-end copper cable do the job?
It actually can't, and that's the whole physics problem Kramer is solving here.
Oh, really?
Yeah, if you try to push a full 18 gigabit per second signal, which is what you need for true 4K.
Yeah. Through a copper wire for 100 meters, the electrical resistance, it completely destroys the signal. You'd get a black screen.
So the data literally just dies on the way there.
It's gone, exactly. So this cable is what they call active optical. It's a hybrid fiber cable.
Okay.
So it has these tiny converters inside the heads. It takes the electricity from your source, turns it into pulses of laser light, shoots it down these fiber optic strands.
And then turns it back to electricity at the other end.
You got it. Light doesn't have resistance like that. It doesn't fade over distance the way an electrical signal does.
That makes a lot of sense. And I noticed the specs really highlight 4.4.4 color sampling. Usually with long cables, I see them drop that number to like 4.2.0 to save some bandwidth.
That's the cheat code for cheaper cables, yeah.
Mm-hmm.
They basically throw away some of the color data to fit the signal through the pipe. This cable, it doesn't compress anything.
So 4.4.4 means what exactly for the person watching? It means every single pixel gets its own unique full color information. If you're displaying, say, a spreadsheet with tiny text or medical imaging in a hospital, you absolutely need that level of crispness.
And it also mentions immunity to EMI and RFI. That's the other benefit of using light, I'm guessing.
It's a huge benefit. Think about a factory with massive motors or a hospital with MRI machines. Copper cables, they act like antennas. They just soak up all that electronic noise.
But fiber is just glass.
Just glass. It completely ignores magnetic fields.
Okay, but now here's my hesitation. Fiber is glass. If I'm an installer trying to snake this thing through a tight conduit in a wall and I pull too hard, I mean, snap, game over, right?
That is usually the deal breaker, but Kramer did something really clever with the engineering. First, it's wrapped in Kevlar, so it's tougher than you'd think. But the real genius is the pull-through capsule.
I saw that in the diagrams, the big HDMI head, the part that always gets stuck on things. It actually comes off.
It's detachable, yeah. Underneath, there's a tiny little micro HDMI connector. You snap on this protective pulling capsule, and suddenly the whole end is barely wider than the cable itself.
And the cable itself is only, what, 3.4 millimeters thick?
It's tiny, so you can pull it through incredibly tight spaces, bend it around corners with a tiny 6mm radius, and then when it's through, you just snap the full-size gold-plated head back on.
That solves a massive installation headache. But then there's the other issue. What happens if, the building catches on fire? The spec sheet made a big deal about it being low smoke and halogen free.
That is strictly for the pros. If you run cable through what's called a plenum space, like the space above a drop ceiling where the air circulates.
Right, for the HVAC system.
Exactly. You can't use cheap plastic shielding. If standard PVC burns, it releases this horribly toxic gas. This cable is designed to basically self-extinguish and not poison the building's air supply. It's a building code thing.
So you're not just paying for the cable. You're paying for the signal range, the clever installation engineering, and the safety rating.
It's a piece of infrastructure. It's not an accessory.
I guess that softens the blow of the price tag a little. Though I did see a 10% off code at checkout.
Which brings it down to what? A cool $800?
Hey, $80 is $80. But seriously, it puts it all in perspective. If you're building a stadium or a mission-critical operating room, you can't have screens flickering because someone cheaped out on a cable.
You can't. And the cost of ripping open the walls to replace a failed cable is it's astronomically higher than just buying the right one in the first place.
It really makes you wonder about the future of our own homes. We're already pushing 8K, we've got VR headsets, all these massive data streams.
We are absolutely hitting the physical limits of what copper can do.
So, are we all going to eventually have to retrofit our living room walls with optical fiber just to watch a movie?
If our screens keep getting better and better, I'd say it's pretty much inevitable.
Something to think about. Thanks for walking us through this.